I'm Sruba. I'm the ATX for Southern California. I've been here. This is our third technical session. I think I remember some of you from the last two. So the first one was on, the first two actually were on simulation. The first one was about Cadence simulation technologies, APS and Spectre X. And the second one was focused on RF, Spectre RF and our RF simulation technologies, as well as RF functionalities in Virtuoso. So today I'm going to tie a lot of this together, and we will focus on Virtuoso ADE products, Explorer and Assembler, and I will also kind of tie in some of the UI related kind of front end to the simulation technologies today, so it all kind of makes sense at the end of it. And we will also talk a little bit about one of our future sessions. So I plan to talk a little bit about Virtuoso RF and EMX just to kind of segue into what's going to happen. So again, as we've done in previous sessions, feel free to stop me, ask questions as we go along. And some of our slides, it may appear that I'm kind of jumping from one topic to another, but that's because I want you guys in an hour and a half or so to get to know some of the highlights of Assembler and Explorer. Just enough information so you can go back and try all of these functionalities yourself. So our Virtuoso design platform actually has a lot of different products built into it. We have ADE Explorer, we have Virtuoso ADE Assembler, Verifier, and VVO. So today I will talk mainly about Assembler and Explorer, and like a slide on Virtuoso variation option, which is our advanced statistical analysis capability, and a little bit about Verifier, which is analog verification. But Verifier and VVO I'll cover minimally. If there is interest, we can always do a session on that. So as if you guys have used Cadence, you've obviously used our schematic editor to start your design. And we have talked about the Spectre MMSim, which is one of the blocks here. MMSim is basically APS, Spectre X, Spectre RF. We've talked about that. And on November 17th, I will have one of our experts here in layout, Nancy. She will be talking about our Virtuoso layout product suite. So today, let's focus on Assembler and Explorer. So guys used Virtuoso L and XL, right? So L and XL are really end of life now. You need to move to Assembler and Explorer. So again, do not get intimidated by that, because really the way I moved from L to Explorer is by accident. I just kind of said, oh, save as Maestro or something, and then I was in Explorer, nothing really changed, no database really exploded, nothing happened. So move, if you're in L, move to Explorer. If you're in Excel, move to Assembler. So let me tell you what Explorer is. So L is basically single test bench, right? And Explorer is the same thing, but you have some really good added functionalities in Explorer, which is you are able to do Monte Carlo and corners for single test bench, which you could not do in L. And Excel is multi-test bench, and Assembler is also multi-test bench with quite a few added functionalities, which we'll talk about today. And Virtuoso variation option is our advanced statistical analysis capability, like high sigma, worst case corners, device mismatch, contribution, and all of that. We won't go into details of that, but if that's of interest, we could definitely do a session on VVO. And today actually I have slides on AD Verifier. If we do not get to it because of time, when I send the slides, Constantine, there will be about 15 to 20 slides on Verifier. And it's like, Verifier is like analog coverage. Like, you can see at the top level, it's good for project management. You can see at the top level, if you have, say, RF front end, how many of my specs are being met in the LNA, in the mixer, in whatnot. So you can actually see, oh, I pass 80% of my specs or something like that. So it is like analog top level verification cockpit. Today we will talk about, let's start from here. So as I said, if you are in ADL, you can very easily just move to Explorer, single test bench to single test bench, very easy. If you use ADXL, move to assembler, again multi-test bench to multi-test bench environment. In fact, assembler and ADXL look so similar. If you do not look at the top tab, you wouldn't know where you are actually. They are almost the same. So a lot of our customers ask, why did you move then? Why did you kind of make all this effort to go from L and XL to assembler and explorer? And the reason is L and XL was very old code, and for every state that we saved about 20 files. And I think after a while, even we didn't know what a lot of those files were, and so it took a lot of time to retrieve and to save. And so this is like an entire restructuring of our file systems, and this is almost like 100x improvement in terms of retrieval and saving time, because we are not saving 20 files per state, we are saving 1 file per Maestro state. So that was the whole driving force behind doing this. So again, I have talked about this before, and I will have links to videos for a lot of these functionalities in these slides. And these videos actually are made by our own product engineers. So they are actually really like 3-minute, 5-minute videos on these different functionalities, like where to move the cursor, how to click, how to save, and that kind of stuff. And those are all through support.cadence.com. So if you do not have a support.cadence.com website account, please get it. I'm sure you have information on that, right, Constantine? Great. So here, how do you create a Maestro view? So if you are in ADL and you want to move to Explorer, so Maestro view is basically, Maestro is the underlying data structure, the infrastructure for Explorer and Assembler. So when you move from L to Explorer or XL to Assembler, you save it as a Maestro view. And once you save it as Maestro view, you've pretty much moved on to Explorer or Assembler. So these are kind of the steps and how the UI is going to look. So if you go to cell, view, open with, and if you open with like a Maestro view and you select AD Explorer and you name the view as say Maestro 1 and you say OK, basically you are in Explorer already. And that is how easy it is actually to move. And if you are in ADXL, go to Cell, View, Open With, and then you select Assembler, and that's it. You are already in Assembler. So you need Explorer and Assembler licenses to be able to do that. So I'm sure you guys have quite a few Assembler and Explorer licenses. And one thing I want to mention is with Explorer and Assembler licenses, you can use them for L and XL. You shouldn't, but you could. That's not a problem. And one thing is, once you save an L or XL test bench in Maestro view, you cannot go back. Meaning once you save it in Maestro and you make some modifications, you cannot open that modified test bench in L or XL because it's already been moved to Maestro. So that's the one thing. So you cannot really parallelly do in L or XL, but So this is how the AD Explorer looks like. It does not look a lot like ADL, it looks more like XL. The reason being that, now below the analysis portion and the design variables portion, you can actually have Monte Carlo, sweeps, all of that available for single test bench in Explorer. But then again, and here you have your expressions, you can set your specifications, and once you hit the green button to run your different analyses for this one particular test bench, you will see how many of them passed, how many of them failed, and all of that. So again, corners are available. You can set up corners again for Explorer and for Assembler, for single test bench and for multi-test bench. So before you were not able to do that in ADL. And Monte Carlo is the same way. Monte Carlo was not available in ADL, but now in Explorer as well as in Assembler for single or multi-test bench, you can set up Monte Carlo. And these screenshots kind of just show how to set it up, like a snippet of it. And if you have any questions or deeper dive questions on how do I set up Monte Carlo in Explorer, Monte Carlo in Assembler, just go to support.cadence.com, and there is from user guides to rapid adoption kits, we call them racks. So if you even search for rack assembler or something like that, you'll get like a GPDK tarball. You can actually download it, and you'll get like 20-30 page of step by step on how to do it. So my goal today is to make you aware of all the different functionalities that are available, so you know if your design needs it, you can go find it or it's available. So how do you transition between Explorer and Assembler? Believe it or not, it's as easy as hitting this upward arrow or this downward arrow. So if you are in Assembler, in the top left-hand corner under the data view section, there is this downward arrow. Once you click on this downward arrow, you will go into the Explorer view, because Assembler is at the top, multi-test bench. If you hit the downward arrow, you will go into the Explorer view, and the Explorer view is the single test bench view for that particular test bench, and that will then it will open up Explorer, and you can kind of deep dive into that particular test bench. And if you are already in Explorer, you want to go up to the multi-test bench level, then hit on the upward arrow, and you will go into the multi-test bench level. Any questions, anything, do stop me and ask. So again, once you in Virtuoso Assembler, one thing to keep in mind is you can sweep the local as well as global variables. So just remember, before all you could do was sweep global variables, but now for different test benches you can actually have overrides. So even if you use a global variable to sweep say 9 out of the 10 test benches, on the 10th test bench you can actually say I just want to sweep the local, not the global. If VDD, if you have VDD as a global variable, for 9 of them you can sweep it one way, for the 10th one you can sweep it a different way. So you can actually sweep local and global variables in Assembler. So again, model files, simulation files, all of these can be shared across test benches in Assembler. You just copy them over, and you can share the same simulation and model files across all these test benches. So I mentioned that we won't talk much about the advanced statistical analysis capability, but just want to talk about Monte Carlo. So we can do statistical analysis, which is task driven. Like the first one is what? Brute force. You can say I want to run 200 Monte Carlos, which is fine, because if you think you're going to find the worst case corner using 200 simulations or 2000 simulations, you can run brute force Monte Carlo. Or you can say I want to be able to do 3 sigma yield, run enough Monte Carlos or run enough simulations so I have 3, 5 or 6 sigma yield, and then you can use the second button here and type a number 3, 5, 6 sigma, and we will do the necessary number of Monte Carlos to be able to get there. Or you can actually use the third button and say create a worst case statistical corner, and we will do that. And there is also like a fourth one which says if you are a very statistical savvy person and you want to do all of this setup yourself, then you can use the last one where it says, okay, I'm going to enter all of these numbers to be able to do worst case corners or high sigma, whichever one you'd like to do. So there are different ways. These are all kind of task driven, so that way whichever approach you want to take, you can kind of use the UI to do that, and this UI is available in Assembler. Just remember that I mentioned VVO for advanced statistical corners. It is not a separate tool, it is just a way of licensing. So if you have Assembler and you want to do advanced statistical analysis, as long as you have the VVO license available to you, you can do all of these advanced statistical analysis, but through Assembler. So VVO is something that is accessible through Assembler. So it is like the front end for VVO. If you do not have a VVO license, what happens is you will, if you want to do any of these advanced statistical analyses, it will just be grayed out. It will show that you don't have access to it. So this is just how the output looks. And then there is run point. So if this is another kind of functionality of assembler, so you can identify one point and then you can run it across corners or across sweeps. So that is something that was not available before. Expression builder, so that is something that is very new in assembler, which was not in Excel, which is, you know, if you're like me, if I type an expression, I never get it right. It's all the parentheses and I don't know, forward slash, backward slash, by the end of it, I don't even know what I've typed. But if you, when you have, this is expression builder is amazing. So if you actually start with say a signal and then you can build it up. You can actually build up, do I want the absolute value of this, do I want this over that, you just keep building it up and it actually gives you ideas. Oh, is this what you want to do, is that what you want to do? So this is really helpful. So use the expression builder capability, and since I do not obviously have time here to go into screenshots, I have actually attached article numbers and videos. So if this is not clickable, all you do is go to this article number at support.cadence.com and this is the video of it. So the videos is what I talked about. These are like 5 to 7 minutes or maybe even shorter. This will just show you where to find the expression builder and how to kind of just one basic example, and then you can go from there. So I have videos of a lot of these. I just thought it would be really useful information for trying out after we are done here. So again, this is another functionality. So I am going from one functionality to another. I am not like trying to show you how each of these works. You can go back and look at the videos. So again, if you have a particular expression that you have identified that is an output of TREN or AC or whatever, you can actually sweep it across corners. And that is something that is available both in Explorer and Assembler for single test bench or for multiple test bench. The next thing is waveform comparison. This is something we did not have before. So you can actually, you say you have an S parameter output of for something, and then you have say an S parameter file that you save from somewhere, which was say the measured one. You want to see if the simulated and the measured are close to each other at all. So we have a waveform comparison tool where you can actually compare what you found, what you simulated, and what you have maybe from measurement equipment, and compare them. So the waveform comparison is something that is very commonly used by people. MATLAB integration. So again, I'm going from one topic to another. So the previous one has kind of no connection to this one, but I still think it's useful information. So MATLAB integration is something that a lot of our customers really wanted. So in Explorer and Assembler, you have output expressions, and embedded in these output expressions, you can have MATLAB expressions built in there. And so if you have MATLAB license, again, Cadence does not own them, but if you have separate MATLAB licenses, we will call the MATLAB license and we will evaluate the expression, and at the end of it in your outputs, scalar output, whatnot, or waveform, we will evaluate it and give it to you. So you can have MATLAB expressions built into the output expressions for Assembler and Explorer. But for that you'll need MATLAB license. We do not supply those. And then Viva Assistant. So what is Viva? Viva is our waveform display tool. That's all it is, and it is all part of Virtuoso. So when you have Assembler or Explorer, Viva is the waveform viewer for it. And one thing that is there in Assembler and Explorer, which was not in L or Excel, is these waveform assistants are all docked into the Explorer window or Assembler window. If you want to undock it, you can stretch it out. You can kind of take it out and have a separate window, or you can connect it back and dock it in, and it's just kind of, it's all there in one place. That is what it means. Waveform balloons. So again, I think I have a video also, or if not, just go to waveform balloons in support.cadence.com and see there are videos to show it. So basically you can attach balloons to different points in your schematic. It could be even a few levels of hierarchy down, it could be at any level of hierarchy. So when once you've done a simulation, then actually at the points where you have the waveform balloons, the outputs at that points automatically get plotted and displayed on the schematic. You do not have to go to results direct plot or go to a waveform viewer separately. So again, if you have for quick plotting and visualization, you can have the plot all waveforms, and if you do that, then almost instantaneously you can have all of your plots available as opposed to go to separate waveform display. This is a capability that was actually that was requested by a lot of our customers, and this is called real-time tuning. So this in no way replaces sweeps or anything like that, but what it does is, in the real-time tuning button is right here, like at the top here. So once you click on this button, what happens is something like this opens up, that the design variable section opens up, and then there is a slider there. So if you hover over any of those design variables and move them, what you'll see is on the right side, there is the waveform thing. So you will see, if it's say AC analysis, the output of the AC analysis, you will see immediately how the output changes when you change any of the design variables. In fact, you don't even have to change all of them at the same time. But if you want to change more than one, you pause real-time tuning, you change 2 of them or 3 of them, and then you unpause, you will see the effect on the waveforms right away. I would not obviously use it for long analyses like PSS or HB, because it makes no sense, you know, but this is only for quick and dirty simulations, more like, okay, let's see if I'm trending in the right direction, that's all. It is not to reevaluate 1,000 asserts and checks and everything and re-netlist and come up. It should be like quick, a few second simulation. So again, another really important functionality which actually helps you with saving time and saving licenses of simulators is something called run plan, which we did not have before, and that is available through assembler. And again, I think I have a link to a video also for run plan. Is if you have say ADXL and you have 20 test benches and you set it up, but in reality if the first 2 say measurements fail, you know, and then first 2 simulations say fail, you should not really run the remaining 18. But the thing is, in Excel there is no smartness built into it. Once you hit the run button, all of them will use as many MMSims as it needs, and it will finish it, even though the last 18 should never have been run. So if you have a situation like that, then run plan is great, because if you have say run 0, run 1, run 2, and then you say you have conditional run plan. So you say if run 0 and run 1 do not pass, don't run the rest of them. So that way it will just stop. You can go home after you start it, but it will not run all 20 just because you said so. If you have the conditional runs set up like that, so if run 0 and run 1 fail, we won't run anymore and not take away licenses from everyone else. In your case, you guys have a lot of licenses, but for paying customers, you know, a designer takes away other people's licenses for frivolous simulations that are not needed. It is very useful. And the other thing is, you can actually pass this output of run 0 to run 1, use it as an input for run 1 and go on to run 2 and so on. So you can actually pass the output of 1 of the run 0 to run 1 and so on. So that is something that is really useful. And this is run plan was not there in ADXL, but it is in assembler. And you can import run plans. Actually, you can import the run plan of one test bench into the run plan of another, and that is possible. So you do not have to type it all up and set it all up. If you have similar test benches with similar signals, similar outputs, you want to kind of reuse them, you can reuse. You can kind of import it and then change if you like. Like here, if you want to what to import, you can actually say I want to import the run plan, and you can import it from another test bench. And run plan actually is something which is very useful, and here is the run plan demo, and there is this article number. Go to support.cadence. I think this is clickable. Yeah, it is. So, and in case it doesn't work, you can actually type this article number and watch the video of run plan. It shows you conditional runs. It shows you how you can actually pass design variable outputs from one run plan to another, all of that. And command line scripts. So, this is something which is, you know, if you want to run regression, I don't know, you guys probably don't, but if you want to run it in scripted mode, and suppose you have set up your assembler with all the complicated ways you want to, you've set up a run plan which is exactly how you like, and then you want to kind of do it in batch mode, you can actually say save as Ocean script, like we had in ADL also. You could save as Ocean script. You can do it here too with all of the fancy stuff built into it, and then you can run in batch mode. That is also possible. Yeah. Yeah. So we also have device mismatch contributions, and you know, you can see which are the biggest offenders, and this is hierarchical or flat. And for mismatch contributions, actually you will need license of VVO, but it is all accessible from assembler. I don't know if you guys use a lot of checks and asserts, I'm not sure, but if you guys use a lot of checks and asserts, you can set up the checks and asserts, and then these checks and asserts assistance, you can set it all up, and once you run the simulation, you will see how many violations you have. So this is very crucial, I think, the waveform plotting templates. Here, if you have, say, so here you can actually say, I want to customize my output waveform. You want to customize in such a way, you have a grid. Suppose you have a Maestro view, say you have an Explorer test bench or an assembler test bench, and say S parameters. You want all your linear stuff there, noise circles, source stability, whatnot, you know, you have all of those, S11, S12, and then you can call it something, you can say I want a grid of say 3 by 3. Whatever, you can figure that out, and then you call it say my test 1, and then you save that waveform plotting template with a Maestro view, and one Maestro view, say one Maestro view is, say it has PSS, harmonic balance, S parameters, and say for the linear stuff you call it SP plot or something. For the large tone you call it say HB plot or something. So you can have multiple plotting templates for a test bench, and whichever one you want to load, you can load that, and then actually you can load that, and so this is how the plotting templates look. So this was a grid of, I guess, 2 by 2, but you could have any number. You can have 8 by 10, whatever makes sense for you. And these plotting templates are very cool because you can mix Smith chart, you can mix rectangular plots with Smith charts. You can have a Smith chart have 2 grids instead of 1, make it bigger. You can do a whole bunch of things, and these are great for design reviews. These are also good for just sharing. So this is really something that customers wanted. And the other thing is so this is where the save the plotting templates in Explorer Assembler. This is the button. You know, sometimes I don't know which button is what, so that's why I have a big red arrow, and then it will actually tell you how. So you can say plotting template name, like I said, call it your SP test or my name, whatever it is, and then you can have a description. You can say I want this plotting template to have large tone and linear, however, you know, so this you can actually have a description, have a name, and then use the plotting templates in subsequent runs, like you can actually append to them. The append works, and this did not work in one of the earlier 617, so I would say go to 618. And then we talked about plot all, MATLAB integration. I'm not going to go over the details, it just is a nicer looking slide. I want to go to, this gives you a very high level or just brief screenshot of what verifier is. So verifier needs its own license, but what it does is it gives you analog verification capability. There was no concept of analog verification before. The digital people always had digital code coverage, digital verification. We never had analog verification. I say we because I consider myself only analog and RF. Not that there's anything wrong with being the digital side, but this is all I know. But the thing is, when you have, so what verifier lets you do is actually really powerful. A lot of our customers use it because verifier, you can input or you can bring in specifications from assembler. So if you have assembler views of, say, your LNA, your mixer, your power amp, whatever it is, and then in each of these verifier blocks, you can point to the assembler views of these separate building blocks that make up your system. And then, or you can actually bring in inputs or specifications using Excel, using CSV files, or assembler views. And then these specifications, then you run with one press of a button, you run all the blocks. So basically you are running all of these blocks and seeing how many of your tests pass or fail at the top level. So it kind of, instead of running all of these test benches separately in assembler view, say if you are a project manager and you come in the morning and you do not know this particular guy in this particular block may have changed something overnight, someone else did something else, you just point to the latest assembler views or the latest spec and you run one click of a button, you will see how many of your tests are passing or failing at the end of the day. So, and you can do regression as well here. So I'm not going to, so this is a very typical Explorer workspace. This has your expressions written here, this has your specs here, your tests, your for a single test bench, your design variables, sweeps, corners. This is how an Explorer workspace looks. This is how the modified one looks. If you want to have the waveform docking also done in an Explorer, you can do it all in one shot, and you can have multiple modifications. Now I'm going to come to something that we talked about before, and I want us to kind of remember how the Explorer, Assembler, the Virtuoso front end for our simulation technologies. We talked about how powerful our simulators were, how amazing they were. However, you can get to all the amazing stuff only if you know how to start them. And the way to start them is through Virtuoso, Explorer, and Assembler. So here in Virtuoso, you go to, again, you have to be in Explorer or Assembler to be able to see the Spectre X button. If you, for some reason, say, wow, Sruba slide had a Spectre X button, but when I open my GUI, I see nothing, that's because you're in L or XL. If you are in Assembler or Explorer and you are using IC618, you should see Spectre X as a button there. If not, definitely call us, but you will see. And how do you start Spectre X? We talked about all the greatness of Spectre X. How do you start it? You start it using this button. And once you enable Spectre X, all of this beautiful stuff will come up. Until you enable it, if you have APS enabled, you will see none of the Spectre X details. We talked about it. Again, I wish I had the Cadence freebies today. Be sure to come next week for Jared's presentation. We will have freebies, and I wanted to have a quiz. That's why I had these slides. But I know you get the mug only if you pass the quiz, but then the mugs didn't come on time. So no quiz, but I will still tell you what it does. Remember, we talked about the 5 settings: CX, AX, MX, LX, and VX. MX is like moderate of APS. CX is like conservative of APS. LX is like liberal, and AX and VX are the 2 new modes. AX, I would say always start with AX if you are doing an RF test bench and you are not sure which one to use, and VX never use for RF, LX and VX, but VX is great for functional level top, analog top functional level verification. You want to use VX because that has that can handle capacity that APS could never even think of. And previously, before Spectre X, you would have to go to a FastSPICE simulator to handle that level of netlist, that size of netlist. So now you can use VX. But still, Spectre X is still an analog simulator, so it's not, it won't handle pure Verilog, but So again, just to kind of refresh, again there is post layout parasitic optimization. If you choose MX, we will choose MX for you, but if you want to kind of not use the handshake mode of preset with post L preset, you think you understand your design and you say, hey, I need a preset of MX, but I want to do aggressive RC reduction. I could use LX or VX for post layout optimization. You can do that. Just like multi-threading worked in APS, multi-threading works in SpectorX just the same way. You can use manual and say 8, 16, 32, 64, 128, whatever, or you can use multi-process, which is new in SpectorX and available through this UI. Again, we said up to 128, you do not really need to use multi-process, but afterwards, if there's a necessity, we can definitely give you more information. So all of this is available through Assembler and Explorer. If you guys, any of you do RF designs, please, this is very important to you, this slide then, because a lot of our convergence problems come from S parameter non-convergence. Yes, I see a lot of heads shaking there. Yes, so we are aware of that. Not only in time domain, but also in frequency domain, there is non-convergence with S parameters. So we used to have spline, rational, BB spice, all of these interpolation methods. Now we have something called default, and this is how the UI looks. So you have in analog lib, you have endport, you bring in your S parameter file, use the default option. The reason is the default lets us actually use different interpolation methods at different points of at different times of the simulation. You will not be able to do that otherwise. If you choose rational or spline, that is all the way, the whole simulation. Of course. So again, I talked about this before. I want to remind everyone, if you want to speed up your simulation and you know exactly at what point in time something happens, use dynamic parameters. Because what happens in dynamic parameters is you could sweep your temperature, say from 0 to 10 nano, I want temperature to be something, 10 to 20, I want something, whatever. Or you can actually say change your tolerance parameters also. You can say I want rel-tol of 1e minus 2, which is very loose for the first 20 nanoseconds of my simulation, because I don't care about accuracy. From after 20, I care, so I can go on to something better. So you can actually speed up your simulation using dynamic parameters, and this is something which is very useful if you know at what point in time you want to do it. If you don't know at what point in time something happens, then you go to something called event-triggered analysis. Suppose you want something to happen when your PLL is locked. That is an event, and you want an action to happen based on that event, because you don't know when that event happens. So you cannot use dynamic parameters. You cannot say at 20.9 I want this, because you don't know PLL will lock at that point. So event triggered analysis, I don't have a slide on it, but go to support.cadence. Event triggered is something when you do not know the point in time. Again, I just want a refresh. So best practices for RF analysis, if you want to use HB, use the HB button. Do not go to harmonic balance from the PSS form. That is totally not advised. So go to HB from HB, because all the enhancements in harmonic balance are happening in there. And another thing is, since we know harmonic balance works with number of harmonics being extremely important for simulation time and accuracy, set to auto, because that will take the trial and error out of your problem. It will become Cadence's problem to figure out the number of harmonics. And if you do not know your time to stabilize, just use decide automatically. Do not try to figure out if you don't know when your circuit stabilizes. So we talked about, so the HB UI, the form is very big. It has a lot of functionalities. I talked about decide automatically for transient aided HB. I talked about setting auto for number of harmonics. Then there is the large signal S parameter analysis capability, the XDB compression, and also load pull All of this is part of the main HB form, just remember that. I talked about dynamic parameters. Again, if you have an autonomous design and you want Spectre RF to tune it to the right oscillation frequency, you want to actually use a design variable to help tune it, you can actually set that and set the number of steps, the tuning range, and that you can use for getting to your oscillation frequency. We also have the XDB compression point built into HB. This is a small screenshot of the part of the form that has the XDB compression point. So, this is just a sample output. Again, if you want to know more, go to support.cadence. This is our envelope analysis wireless flow. So, we support a lot of wireless standards, 802.11, multiple flavors, then 5G new radio, we have Zigbee, Bluetooth, and all kinds of so many different standards we support. If you want to do your bit error rate constellation plot, EVM, power spectral density, ACPR, and all of that and you're using a standard that we support, all you have to do is go to the wireless flow, and then because we know the sequence, we know how that standard is, you do not have to enter any information really. All we ask for is number of harmonics, oversample factor, same thing that HB needs pretty much, and then your accuracy defaults and set it to level 1. And what happens is then you will get constellation plots, EVM, bit error rate, power spectral density. However, if you want to supply us your own I and Q files and it's not any of the standards we support, then it's the classic flow, and then you will actually have to give us a lot more information because we do not know how those sequences are or any information about that. So, you know, under, I think it's called, I forget, so basically I think it's part of analog lib, and then that is all the sources. So, we have LTE source, we have 5G NR source, we have 802 whatever. So, you pick whichever source that is supported by us. If you pick a source that's supported by us, then like 5G NR source is actually very different. It's a parameterized source. So, you can pick and choose, you know, it's like a whole parameterized source. So, you So, again, speed versus accuracy, you can do real two-tone IP2, IP3, IP5, or you could do like rapid IP3 where the second tone is considered a small tone, and this is where the UI is. So, I have these screenshots just so you guys know how to set it up or how the setup, a general setup would look. That's all it is. I mean, it's like a sample setup, but you can always obviously change these numbers. So, low memory mode in harmonic balance, if you enable low mem equals yes, then what happens is, you know, if you know for sure that this will be a problem, memory will be a problem, then you set it. Nice to know things in RF, I just made a list of things. So, this is the screen I was talking about. So, here we put in the source, it's an LTE source. So, this is the input source we were talking about for wireless. It could be LTE, whatnot, yeah, you know, 5G, and this is the W probe I was talking about, the output probe, and then you can have actually, you can run envelope even using models, like if you have a PA, you know, as a Verilog model, doesn't have to be transistor level, and then you put your source here, and then this was LTE, but you could have anything, and then this W probe, once this W probe is put in there and then you set up envelope following analysis, what you're going to get is something like this. You get your constellation plots, ACPR, power spectral density, all of them. So, I think I talked about this before. You know, for RF we have done some things that are very, that saves you time basically. You can look at your waveforms and figure out the same things, but these things are kind of good to know. We have these different plotting types here, and then you can see the sideband contribution, which sideband is contributing to how much. You can actually do the value at before. I mean, you can look at your waveform and know the value at, but we let you also kind of figure out if you can say value at this frequency or value at these harmonics, so you can do that. This is, and the other thing, again, I may have told you before, but I will have to tell you again, do not discount the importance of this little button, add to outputs, because if you have this enabled and then you do all these difficult measurements, you know, noise circles or whatever it may be, you know, load stability, source stability, and then you have that add to outputs enabled, what happens is the entire expression gets written out in your assembler or explorer, expression section, and you don't have to use it all the time, but if you ever need to, you can just plot it or save it. That is a huge benefit in my opinion. I already talked about waveform customization. Remember, we did that little the grid thing. So here it is just another slide that shows that. If you choose your grids, you can have your Smith chart over 2 grids. You can kind of set it up just the way you want it and call it a particular name, and you can bring it up every time. And if you want to see one of these plots at a time, you can use it in card mode like here, or you can go back to the grid. And this is where it is. You can have a particular name set up. I think I showed something similar before. You can have the name here, you can have the description here, and for a maestro state, you can have multiple plotting templates. And that is something I think users really wanted. So again, add to outputs will help your expressions get here. I said value add, we've done that. We talked about real-time tuning. Again, verifier flow. So verifier, I just talked a little bit. I don't know if that's of interest. Is that of interest to you guys? But anyway, this is how it looks. And with the one green button, all you can do is you can kind of simulate multiple blocks, and each block, one block may have a spec that comes from a CSV file, another block a spec from an Excel file, another block could be assembler view, or all of them could be assembler view. Just remember, assembler is a prerequisite for verifier. You cannot have an explorer view or an L or Excel view. You have to have an assembler view as an input to verifier, and then once you hit that green button, basically we will simulate all of these blocks, and then these are the specs that came with these blocks, right? And then we will say which ones passed, which ones failed, and at what percentage. So yes. So this is kind of the mapping between the requirements, and so you can actually right mouse button. Actually, you know, you can right mouse button into any of these specifications, and then you will see what you actually asked for and what you got. So this is how you can have specs as Excel spreadsheet or CSV, and we support a whole bunch of different other formats. This is how you run simulation, and with the button here, and then this will show what percentage passed or failed. This is more like verifier uses the same ADE job policy. You know, you guys are probably familiar with how you set up your job policy for Explorer and Assembler, or L and Excel, and verifier pretty much uses the same kind of job policies. So this is how the results tab would look in verifier, and it will basically show the specs and what passed and what failed, and you can kind of right mouse button into any of those and see what you asked for and what you got and how far they're different. So you can also have a waiver, like you can override a failed verification, and then you can manually say I don't care about it, you know, whatever, so that will improve your percentages if that's what you want. These are just more details, and you can create regression. You can create a batch script for any of this effort. You can set up coverage goals for verifier. Yes. Yeah. So they basically, this is the create batch script. So you set up your verifier with however you want it to set up, and once we say, it's like create ocean script, right? Create and then what you can do is you can actually VI it or edit it however you want it, and then rerun it.
Or I can like load it again, right?
Yeah, you can load it. Yeah, that is what we kind of want you to do. But yeah, you can just edit it and change, have different flavors of it if you like. Oops. Okay. Coverage goals. You can monitor coverage. So, so one thing I want to mention is, I'm not going to details of it, but if you guys do digital design and you use vManager for digital coverage, verifier and vManager kind of have a way to shake hands at a certain level. So if you have your analog code coverage, analog verification results, and you have done all your code coverage and digital verification using vManager, which is I think now called Verisium. Not sure why we've changed the name, but then I did not change it. But vManager, Verisium, whatever you call it, so the vManager, which is the digital verification side, and verifier do shake hand at the top level. So again, do you guys what do you guys use for extraction? Do you guys use Quantus? Do you guys use something else? Calibre, okay. So if there is any interest, the thing is, once you look at Virtuoso RF platform, which not incorporates, but basically using EM Assistant in Virtuoso RF platform, you bring in EMX results, you bring in clarity results, and for EMX is more for on-chip, clarity is for PCB and package, and for the off-chip interconnects, we actually can stitch in EMX with Quantus results, EMX and Quantus for the on-chip and the off-chip interconnect. So if that is of interest, we can definitely do a session on Quantus. And Quantus Smart View is becoming very popular. A lot of our customers who were using other tools are kind of looking at Quantus because they want to have it all integrated. Because you can, and the best part is with Virtuoso RF, when we talk about the EM solvers and Virtuoso RF, you'll see that when you have Virtuoso RF, you do not have to cut out different structures and send it to EMX or send it to Clarity or send it to Quantus and then bring it back and have multiple layouts. But basically you highlight structures and you say which solver should I send it to, and there is an EM Assistant which has a pull down. If you say EMX, for that highlighted structure, you will get the equivalent S parameter of that structure, and the import for that S parameter gets connected seamlessly rather than you mucking around with all the ports. And the same goes for Quantus and the same goes for Clarity. So it is actually a very, very powerful platform. We will talk about that in the right after Thanksgiving in early December. So that is what I was just talking about, the Virtuoso RF platform. A lot of our customers are actually going into production. One of our customers just used our entire VRF flow with EMX, with Clarity, and with Quantus, and using Voltus X5 for EMIR for a full RF chip tape out at GF12. So all of this works very well together. So we will have that session in actually early December, the first Thursday of December. So yeah, so I think whatever, so again, another thing I wanted to talk about is, you know, we have something, so we have device reliability and interconnect reliability. So we have EMIR, electromigration. For EMIR analysis, we have Voltus X5, and for device aging and reliability, we have something called Legato, so which has which has analog fault simulation, which has electrothermal analysis and device aging. So do you guys in any of your classes or research ever worry about device aging and the reliability issues that happen? Say our automotive customers are very interested and worried about it, and so is our aerospace customers. Anyone, I guess, that cares about how my part will function 20 years from now, 10 years from now. Rel Expert is one way of doing it. We have Spectre native device aging and reliability as well. So from Virtuoso L or XL, but now Assembler or Explorer, you can we have Spectre's native device aging capability. So what happens is, if you have say fresh simulation, which is now non-aged regular PDK, and suppose your foundry has to give you aged PDK.
Yes.
So if you have the aged PDK, what we do is you point to the model file for the aged PDK, and then we do stress simulation and end of life simulation and all of that, and then you can do, and all of that UI is on Assembler or Explorer. So basically you point to that model file and then you say, I want it to be aged for 10 years, or I want the aging to happen year over year, and however you want to do it. And then you can do aging plus Monte Carlo, you can do Monte Carlo and then aging, and then you can actually kind of, way it all comes together in my head is, suppose you want to see how is my VCO frequency changed if I do aging and if I do fresh. So you have the fresh simulation of the VCO, and then you have aged it for 10 years, and then you do a PSS or harmonic balance one over the other, then you see final effect of what happened with aging, right? So we do that kind of stuff.
Legato, and you said that Rel Expert is one way that works in Legato.
Rel Expert is one way of doing device aging, but we have Spectre native aging, which is also our own aging tool using Spectre. And I think all the enhancements that we are doing and all of that is available mainly through Spectre native aging. So I would say that is one way to use it, I think. So basically we have 3 flows in device aging. One is for TSMC, and the
TMI, I know that.
Yeah. One is TSMC, and the other is basically we have our own HMOS equations.
Yes.
HMOS and HMOS2. HMOS is for mature nodes, HMOS2 for advanced nodes, and so you can work with your foundry and with us, and then that is basically a way of incorporating aging into the PDK. But of course, with that we have to work with you and the foundry and us all together. And the third one is the custom flow, where you can you get an aged PDK from a foundry, or
And you do the model up, like the
yeah.
stuff like that. Okay.
So we don't care, because one of my customers said, I have incorporated rad-hard effects into your simulations for years. Like, how did you do that? Oh, because my foundry had already incorporated in it. So we don't care. For us, it's the simulator, right? It doesn't know any parameter. As long as it's understood by us, we don't care how you come up with it.
So you can incorporate your own equations for reliability, or you can work with the equation that you provide. And of course,
Yes.
Some fabs have their own models.
Yeah. And then, so device aging and reliability has been around for like 20 years, actually. This is nothing new to us. But we are using this flow now, this infrastructure, we are hoping to leverage to actually do rad-hard simulation, total dose effects. So we are working with different universities to come up with HMOS2 for rad-hard. Not HMOS2, but whatever, HMOS-like equation with rad-hard parameters. And then the other thing is analog. So like I said, we are trying to see if we can do rad-hard total dose, just like 10 years, year over year, however you want to do total dose. But one thing that we often think about is it's not so easy. If you can do average total dose over 10 years, that's 100 kilorad, say. But sometimes even for total dose cumulative effect, there is a radiation profile. If you are going around a certain moon of some planet or something, your radiation, like year 1 may be very different and year 1.5 and then very different. And sometimes if it's very strong at one point, your circuit behavior may change over time. Yeah. Yeah, so that's the thing. We are in the process of researching all of that. So we do not have a solution yet, but working with a lot of universities and scientists to see how best to do total dose. But this is the basic infrastructure we are planning on leveraging. We have something called analog fault simulation, which is I guess now called analog defect analysis, which is you can actually put in fault injection points, current points at different, in your different transistors or wherever, and then you run simulation and you look at sensitivity of each of those fault injection points at the output. Yeah, and that is something we are looking to leverage to do single event upset. If you have single event upset in radiation, and then like even image sensor companies are very worried about single event upset. They don't care so much for total dose, but a single event upset, if you can translate that into putting fault injection points, then basically you can use this analysis capability to look at sensitivity. Yeah. And then electrothermal analysis, we have our own electrothermal analysis inspector, but we also have something called another tool actually, which is not part of Spectre, is Celsius, which for thermal analysis for a lot of our customers use that at the IC level or module level. If you guys have questions, and David here is talking about internships, anyone, any interest? David, you have cards. I have no cards.
Hand out cards.